The aim of this video is to master more challenging polynomial division, and we're going to look at two methods for these ones that might be a little bit harder to do. And you can see that we've got two columns here. On the left first, we're going to do it in the way we've looked at in the previous video, the division of two polynomials, and on the right hand side we're going to look at something called equating coefficients. So you get to choose which method you prefer. They yield obviously the same result. So on the left hand side we've got 3x, and they're the same question on the left and the right. You'll notice in both cases it's 3x cubed plus 2x squared minus x minus 2 divided by 2x plus 1. So alright, we need to get the 2x on the left hand side. Here is where we're looking. We need to get the 2x and the 3x cubed to match. Obviously we're going to multiply by x squared to some extent, but we also need to look at what the coefficient starts at and needs to end up as. And this is where the more challenging phrase comes from. We need to multiply 2 by 3 on 2 in order to get to 3. So, and then the x squared is the other part. So that'll become 3x cubed, which is what we want, and we multiplied by 3 on 2 x squared. And we have to multiply the 1 by 3 on 2 x squared. And we get 3 on 2x squared there as well. And we subtract. And we get 0 in the x cubed column. And we've got 2 minus 3 on 2, which is a half x squared left over. Then we bring down the next term. And we have a minus x there. So the 2's got to become a half, so we need to multiply by a quarter x. So we have a quarter x. And these match. Oh, my pen stopped working. Try again. Okay, it's better. And the 1 has to be multiplied by a quarter x as well, which makes 1 quarter x there. We subtract and repeat that same algorithm. X squareds cancel. We have negative x minus a quarter x is negative 5 on 4x. Bring the 2 down, minus 2 that is, and we need to go 2 times something equals negative 5 on 4. But if you ever need a little bit of help, you can just 2 times something equals negative 5 on 4. So one way of that, we need this here needs to be half of that. One way of thinking it is that if you double the denominator, you halve the fraction, so a must equal negative 5 on 8. So that's what we need to multiply to get our matching x values. So negative 5/8 goes up here, and 1 times negative 5/8 is negative 5/8. The x's are eliminated, and we've got negative 2, which is negative 16 on 8, minus negative 5 on 8 is negative 16, plus 5 is negative 11 on 8. Alright, and that's our remainder. So we've got our answer there. And I've just popped the answer written in the correct way there from the previous video that you'll remember. Moving over to equating coefficients, you note that it says there now that for this alternative method we need to write the identity out like this, okay? Because when you think about it, we're going to be multiplying the given 2x plus 1, the divisor, by to get a cubic we've got to multiply it by a quadratic, and it can have up to 3 terms in it, and then plus a remainder on the end. So that's important to write that out. You need a bit of reasoning there, Okay, so we've got noting that that's given, so it's going to have to start at a squared, work its way down through B, through C, and R. So we've got to find the coefficients. So we've got to find the identity of A, B, C, and then R. And this will give the same result as you can see there in yellow. So let's commence work. So remember, this is an alternative way, as long as you can do one of these two. Some people might find this way. I personally find this way much quicker because I can do those bits of mental math without any issues with positive and negatives and fractions. Other people might think differently and they might prefer this, so this gives you another option. Okay, we start with the x cubed terms. So we've got to work on finding thus a value of a by considering the cubic terms. Alright, so looking for the cubic terms, on the left hand side we have 3. On the right hand side, now how are we going to get a cubic on the right hand side? By multiplying those two terms together. Think, is there any other way of getting a cubic? No, there isn't. So because the only other option is 1 times ax squared, and that's not going to get a cubic. So we have on the right hand side, we have, for the coefficients, we have 2 times a together. So equating them means make them equal to each other, so therefore we have 3 equals 2a, and a equals 3 on 2, or 1.5. And if you look back at the coefficient back over here, you can see that it is 3 on 2. So we've got a match there. So moving on to the squared terms, on the left hand side we've got 2. On the right hand side, how are we going to get squared terms on the right hand side? Now we have to look a bit more closely than last time. So we can go 2x times bx, that will give us that. Now using the 2x, there's no other ways of getting that, but if we look at the 1 times the ax squared, that's another way we can get a squared term. So constant times a squared term, in other words. Alright, so let's put them down. We've got, the first one was 2x times bx, in other words 2 times b if we're just looking at the coefficients, and 1 times ax squared, or 1 times a if we're just looking at the coefficients, which is just a. So that was that one there that we looked at. We're only looking at the coefficients, remember. So we've already found a from the previous line is 3 on 2. So that's 2b plus 3 on 2. Therefore, if we equate left and right, 2, that 2 there, equals 2b plus 3 on 2. Take 3 on 2 off both sides. 2b is a half. Sorry, that should be a b. 2b is a half. B is a quarter. And have a look over on the left hand side. Do you see a quarter there? Yes, we do. That's a match. Going really well. Alright, let's move on. And we're going to look at finding C by considering the linear terms. X to the power 1. So on the left we have -1. On the right we have, how can we get a linear term here? So I'm going to write in green. No, I'm not. I'm going to write in red. In fact, I'm not going to write anything because I can't find the cursor. It's disappeared. Oh, there it is. Okay, so writing in red. So we're looking for a linear term. How can we get that? If we go the 2x by a constant, and if we go 1 times x, so there's two ways of doing that. We'll go through the same process. So 2x times c, so with the coefficients it's 2c. It'd be 2cx, but we're just looking at the coefficients, so it's just 2c, and we have 1 times bx, or as that is 1b, because it's just the coefficients, so 1b. So 2c plus 1b. I'm just writing b. Okay, so 2c plus b, but we know what b is, we just found it there, and so that's 2c plus a quarter, 2c plus a quarter, so equating the sides left and right. On the left -1, on the right 2c plus a quarter equals 1, and take a quarter off both sides, so it's -5 on 4 on the left. I hope you listened to your teacher in junior when he or she said to you how important it is to be good at fractions, right? This should be effortless, all of this mental math with the fractions. Okay, without the mental math, this would be an absolute nightmare. All right, it would take forever. It's long enough as it is. You would be taking 3 times as long if you couldn't do your fractions mentally. So there's a big plug for fractions. Tell all the young kids out there. All right, we've got an errant stylus. Let's try that again. Alright, bear with me. So try again, and there we go. So c equals -5/8. We're dividing both sides by 2, and you might recall before we got -5/8 up the top. Okay, and you can see that there, -5/8, so that matches as well. Now don't celebrate just yet, we've still got to find r, so we've got to look at the constant terms now. So last step, so you can probably see now why I prefer the method on the left. If your mental maths is up to it, definitely the way to go, but this is a good auxiliary method. So we've got -2 on the left, and on the right hand side, how can we get a constant term? Okay, I'm going to write in green this time. I choose green. A long time ago that was my favourite colour, but I don't have a favourite colour anymore. So, right, we can go 1 times the c, and is there any other way of getting the constant? Yes, that it would be called r. So r there, and we've got 1 times c, which is just c plus r. We know what c is. C is -5/8, so we've got -5/8 plus r on the right. So equating left and right, we've got -2 equals -5/8 plus r. Now remember, -2 is the same as -16 on 8. So -16 on 8, r is going to be negative. So -16 on 8 equals -5 on 8 plus r. As I said, r is going to have to be negative. So we have to take off another 11 on 8. So r equals -11 on 8. So it's a 16 bit neater. Okay, so -11 on 8, and you saw from above that match. Then you'd write your answer up just like it is in yellow, and just to show you that the -11 on 8 was there, and you would just go through and finish it off as it is in yellow there.